Hello guys, welcome to the Spring Boot 0 to Infinity course. So this is going to be the fourth video of this series. So let's see where are we currently in this course. So as you all know, this course is divided into two parts. In the part 1, we will learn about the Spring Boot backend foundation from the core Java to how we can secure the REST API. And the part 2, we will learn about how we can scale our Spring Boot application. So what are the topics that we will study in the part 1? So in part 1, we will start with the level 1, in which we will learn about the Spring Code. In the level 2, we will learn about the Spring Boot and the MVC architecture. In the level 3, we will learn how we can add the database to our Spring Boot application using the databases and MySQL and JDBC. And in the level 4, we will learn about how we can add the security to our Spring Boot application. And in the level 5, we will learn about the deployment, how we can deploy our Spring Boot application. So this will complete our level 1. And in the level 2, we will learn about how we can scale our Spring Boot application. So we, from microservice architecture, Kafka, Redis, Docker, Spring Test, and Kubernetes. So currently we are in our level 1 Spring Core. So let's see what are the topics that we have covered till now and what we will cover in the Spring Core. So in this level 1, we have already covered all these topics. In the lecture 1, we have learned about why framework, why there is a need of framework, what is framework, what is the Spring framework, and what is its real world use case. Then in the lecture 2, we have learned about how we can configure the Spring and what is the Spring context and the beans and what are the different methods of adding the bean to the Spring context. And then in the lecture 3, we have learned about the dependency injection. That is in the last video. In the last video, we have learned about the dependency injection, what is meant by the dependency, what is meant by the dependency injection, and what are the different methods of the dependency injection. So what we are going to learn in today's video. So in today's video, we will learn about what is abstraction and why there is a need of abstraction and how we can do the dependency injection with the abstraction. So our today's agenda is this. Then what are the remaining topics in this Spring Code? So in the future video, we will learn about the Spring bean scopes and the lifecycle, proxies, AOP, and transaction. So after covering all these topics, it will cover our the level 1 Spring Code. And after completing the level 1, we will do one mini project and one major project. So what are in the mini project? In the mini project, we will build one notification system using only this level 1 knowledge of the level 1. That is only with the help of Spring Core, we will make one notification system. And in the major project, what we will do? In the major project, we will make a version 1 of our Zomato, in which we will first start with a pure Java and then we will move it to the Spring Core and then see what are the advantages of using the Spring. So in the major project, we will make Zomato clone using only the Spring Core. It will be going to be the only console based application, and we will eventually grow this application to the full-fledged application as we proceed further in this course. So let's see. So let's start today's video. So in today's video, we are going to learn about the abstraction and then we will learn about how we can do the dependency injection with the abstraction. So what we will learn? So first we will learn how we can achieve the loose coupling using abstraction. Then we will learn how we can use the dependency injection with the abstraction, and then then we will learn how we can select the implementation using the primary and qualifier annotations. So after this video, you will clearly understand what is abstraction, how abstraction works, and how it helps us in achieving the loose coupling. So let's start today's video. So in the previous video, I have told you what is meant by the coupling and how we can achieve the coupling. So basically coupling is a two-step process. In the first step, we have learned about the dependency injection, and in today's video, we will learn about the abstraction and what is meant by the abstraction. So let's start. So let's see, before learning abstraction, let's first try to understand why do we need abstraction. So consider one business requirement. So before learning the abstraction, let's see what are the real world problems. So in the real world, without abstractions, the class depend directly on the another classes. If we changes in the one class, then it ripples through the system and code become hard to test and maintain without abstraction. What are the goal of the abstraction? The goal of the abstraction is to decouple the implementation so changes don't spread the code base. So what is the need of the abstraction? So need of the abstraction is basically to decouple the implementation so that the changes does not spread across the code base. Let's study it with the help of one example. Consider one business requirement in which the user checkouts an order and user check out an order and do the payments. So how we can achieve this business requirement? So this business requirement can be achieved with the help of the two class. First we have one checkout class in which there is one method called a complete purchase, and this complete purchase delegates the responsibility of the payment processing to another class known as payment processor, in which there is one method of the payment process payment. So this business requirement can be achieved using these two classes. So let's see how we can implement this business requirement. So basically open your IntelliJ IJ and create the new project, and let's name it for an abstraction with dependency injection, and let's choose the Maven archetype, and from the architecture type select the quick start, and let's create the project. So now our project is created. Let's open our main folder and app folder. Let's first create one checkout class. Let's create one checkout class, checkout, and one PayPal processor for the process of the payment. So let's create PayPal processor. And this PayPal processor, in this there is one method known as the void process payment whose job is to complete the payment. It will take amount and completes its payment. So let's say it first connect to the PayPal API, and let's write connecting to PayPal API. Then it's verify the credentials, verifying the credentials, and then processing payment of, and then let's say payment completed. So there is one, so basically we have one class called PayPal processor in which there is one method called process payment whose job is to complete the process. Basically it's a payment, it's like a payment gateway, and this checkout class uses this dependencies, this PayPal processor as its dependency. So let's create private PayPal processor, and in this there is one method called void complete purchase, and in which it will take one argument amount, and what it will do, it will basically call the PayPal processor dot process payment of what is amount, and let's print out here checkout completed. So basically what we have done, we have basically in the checkout class we have one method called the complete purchase whose job is to complete the payment, and this checkout class delegates its responsibility of the payment processing to another class known as PayPal processor. So from where it will receive its dependency. So in the previous video we have learned about a dependency injection. So let's do it with the help of the constructor dependency and PayPal processor, and let's inject the dependency using the constructor. So now it's done, and let's make it final private so that it cannot be changed. It's become immutable and cannot be changed after initialization. And in the main class, first we will learn the concept of abstraction without strings. So it's a plain Java. So it's in plain Java. So first since it first we will learn about the dependent abstraction using the plain Java, so we will not use any Spring context or the beans. So we will manually create our object. So let's first create the checkout object. So first we have to create one instance of PayPal processor. PayPal processor is equals to new PayPal processor, and now we have to create checkout instance of one checkout, new checkout, and in the constructor we have to pass the dependency that we have created. And now we have to checkout dot complete purchase. Let's say its amount is 200.5, and let's see whether it's working or not. So basically it's working, connecting to the PayPal API, verifying the credential, processing payment of 200.5, and the payment completed and checkout completed. So this is our business requirement which we have implemented using the two class. First one is the checkout class and the second one is the PayPal processor, and the checkout class delegates its responsibility to the PayPal processor for the process of the payment. So let's see. So we have one checkout class depend on the PayPal processor for its completing the payment, and it do PayPal processor dot process payment. And in this we have, in the PayPal processor we have one method known as process payment, whose job is to do the checking all the credential and validation of details and processing payment. And then we have created one, because we haven't used any Spring, then therefore we have to manually create the instance of both the PayPal processor and the checkout class, and we have passed our dependency of the PayPal processor in the constructor of the checkout. So this is an example of constructor dependency injection, and then we have completed our purchase. So all this is looking fine. So there is no use of abstraction in this. So till now it is looking fine. Like, so why there isn't? So till now it is looking fine and the code is also fine. So now you will be thinking like, what, okay, all this is correct, then why there is a need of abstraction? So what is the problem with the current approach? Currently it is looking fine and there is not any problem in the current approach. Let's see what is the problem with the current approach. So because as you can see, our checkout class directly depend on the PayPal processor. As you can see from here, our checkout class directly depend on the PayPal processor. So what is the issue in this? So object is injected, since we have used the dependency injection, but still the type of the object is concrete. So this is dependency injection without abstraction. So basically, in order to achieve the loose coupling, we have two steps. First one is the dependency injection, second one is the abstraction. So we have used the dependency injection, but we haven't used the abstraction. So still it is a tightly coupled. So it's a tightly coupled. So let's see what is the problem in this current approach. So consider now we want to add one or two more payment processor, like Stripe processor or Razor processor or crypto processor. Consider let's say we want to add one more payment processor like Stripe processor in order to process the payment. Then what we need to do? So first we need to write one new class known as Stripe processor. So this is fine. This is not the problem, because if we want to add one new payment processor, then we have to write that class. The problem is that we need to modify the checkout class in order to use that payment processor. So let's see it with the help of examples. Consider we want to add one new payment processor, Stripe processor, then we have to modify our checkout class. Let's see how. So consider in the letter requirement, we also want to add one new class known as the Stripe processor. And let's say it also has the same method of process payment. Let's copy it and paste it here, and instead of here, right here, Stripe API. So now this new payment processor is created. Then what is the problem? Now in order to use it in the checkout class, we need to modify the code of the checkout class. Like, first we need to add one new instance of this, like final Stripe processor, stripe processor, and then we need to inject its dependency into it, like stripe processor, stripe processor, and here we need to add its dependency. This dot stripe processor is equals to stripe processor, and here we also want to check what is the type of the payment that user want to use. So basically string payment type, and here let's add string here private string payment type, and add it here also. This dot payment type is equals to payment type. So basically we have added one new dependency in our checkout class, and also added the payment type that the user will tell which payment provider it wants to use. So in the complete purchase, first it will check if payment type dot equals is equals to, if it's PayPal, then do with the PayPal processor, else if payment type dot equals Stripe, then we need to do it with the Stripe processor. Stripe processor dot process payment amount. Let's see. So basically we have added one more dependency and uses it in our project. So let's, in here we need to create Stripe processor. Stripe processor is equals to new Stripe processor here, and now we need to pass the dependency here, the Stripe processor, and also we need to pass which payment provider we want to use. So consider first we want to use this PayPal, and now let's create and let's name it with the checkout with PayPal, and let's rename it checkout with PayPal. And in the letter of the, let's see now, completed with PayPal, and let's see later user want to do it with the help of Stripe, starting with Stripe. Then what it needs to do? So basically it had to create here and type here and check out with Stripe, and here pass Stripe STRIPE and check out with Stripe. And now, so basically, so what we have done here, so basically we have added one more Stripe processor, added its dependency here, and with the constructor we are also stating the payment type, like from which payment provider we want to process our payment, and then in the complete purchase we have added one else statement, and let's run it. So as you can see, first the payment is done with the help of PayPal API, completed with PayPal, now started with the Stripe, and in connection to the Stripe API, verifying the credential, processing payment of it, payment completed, checkout completed. So basically, as you can see, in order to add the, so what's the problem? So we have added one more payment processor known as Stripe processor. So what we have to done in here? So first we have to write the Stripe processor class, and then we also need to modify the checkout class and added here new dependencies, and also added the else if statement in the complete purchase method. Like here in the complete purchase method, we have written the else if statement and check which payment provider the user wants to use. So every time we added a new payment method, we have to change the checkout code. So this is the example of tightly coupled system. So basically every time we added a new payment method, we need to change the checkout code. we need to change the checkout code and add here. So what we need to do every time we added a new, so first we have to add the new dependency and added it into the constructor and do the constructor injection, and then we have to write the else if statement to check which payment option the user has chosen. So this is a, so every time we added a new payment method, there is a need to change the checkout code. So this is the example of tight coupling, like checkout class directly depend upon the payment methods. So this is the tight coupling. So this is the problem in our code. So as you can see, if we want to add a Stripe processor, so first we have to add here new dependencies, and in the complete purchase we have to add the else if statement to check which payment provider the user has chosen. So this is the example of the tight coupling, like the checkout class tightly coupled with the payment processor class. So this is the example of the bad design approach. Like every time we added a new dependencies, new payment provider, we need to change our checkout class code. But we want something different approach. We want the approach like, if we want to add a new payment method, we only add that new payment class and we don't need to change to this checkout class. So this can be achieved using the abstraction. So this can be achieved with the help of abstraction. So let's see what is the cause of the problem. So why this problem arises, like every time we want to change it. So let's say what is the cause of the problem. What is the cause of the problem? This problem arises. So what is the cause of this problem? So basically the cause of our problem is that our checkout class, our checkout object specify both what it needs, like it need a payment processor, and how it needs. So basically our checkout class specify both what it needs and how it needs, like whether it needed the Stripe processor or PayPal processor, it specifies both what it needs and how it needs. This leads to the problem. So there's one. So let's say, does the checkout really cares how the payment is done? No, because the role of the checkout class is only to do the payment. So checkout class does not care how the payment is done. It only needs that the payment should be done. It doesn't care how the payment is completing. So checkout class only need, like payment should happen, because checkout class only care about the payment should happen, but it does not care whether it's happened to the PayPal, whether it's happened to the Stripe, or whether it's happened to the Razorpay. So what does the checkout class need? Checkout class need only that payment should happen, and it does not care about how the payment is done. So basically the checkout class only needs to know what needs to be done and not how. So this how leads to the tightly coupling between the checkout and the payment processor class. So this is the problem. How? Because our checkout class specify both what it needs and how it needs. But in reality, our checkout class only needs to understand what it needs, not how. If we remove this how from our checkout class, then our class then we can achieve the loose coupling between our classes. So let's see. So think in terms of capability, not implementation. So basically our checkout class only care about the payment should done. It should not care how the payment is done. It delegates its responsibility of how to the payment processor. So checkout, what does checkout needs? Checkout needs a payment capability, not a specific payment gateway. So what does the checkout class need? Checkout class needs a payment capability and not a specific payment gateway. So what does checkout needs? Checkout needs what and not how, and this leads to the concept of abstraction. So basically what is abstraction? So basically our checkout class only need to understand what and not how. Like we want to hide the implementation or complexity from our checkout class. So this is the abstraction. So what is abstraction? So abstraction is the process of hiding internal implementation detail and showing only essential functionality to the user or another class that is using it. So for example, in our checkout class, we want to hide the internal implementation detail of the payment processor, and only we want to show what it needs to done. So checkout class only need of process payment. So we only expose this implementation to the checkout class. So basically abstraction is the process of hiding internal implementation detail and showing only essential functionality to the user. So basically it focuses on what object does rather than how it does. So basically checkout class needs a payment processor that role is to do the process payment. So checkout class does not care how this payment is processed. It only needs what it needs to done, like process payment. So we can understand the abstraction with the help of example. Car as an example. So abstraction basically in the car. In the car, driver uses the steering wheel, accelerator, brake and gear. So these all are the abstraction because the driver only knows that when he presses the accelerator, the car speed of the car will increase, and when he will left the accelerator, the speed of the car will decrease. The driver does not need to understand the how does the accelerator is working, how engine is working, how the fuel is working. So this is the clear case example of the abstraction. Like the manufacturer of the car provided the abstraction or like the interface like as accelerator. When the driver presses on the accelerator, the speed will increase. So driver only needs to know what should be done instead of how. So therefore this is an example of abstraction. So a driver can drive without the internal working. This hiding of complexity is known called abstraction. So basically the complexity of the engine or the fuel burning is hidden from the driver with the help of the abstraction. What is the abstraction in this case? In this case the accelerator, the steering wheel is all the abstraction that are provided by the manufacturer of the car. So the driver does not need to know its internal working of the engine or the steering wheel. So how abstraction can be achieved in Java? So in Java, abstraction can be achieved using the two ways. First one is using the abstract class and second one is using the interface. So but in Spring and clean design, interfaces are preferred. So we will learn about the interface. So interface is like a contract that defines what a class must do, but no, not how it does. So what is interface in Java? Interface is like a contract that defines what a class must do, but not how it does it. And so the class that implement this interface. So interface is implemented by the class. So the class that implement this interface sign the contract like, okay, I will provide this implementation and provide this implementation. So what is interface? So interface is nothing. Interface is basically, what is interface? Interface is like a contract that defines what a class must do, but not specify how it does it. So who will specify how it should do? So the how part is specified by the class that implement this interface should provide this how part and sign the contract and provide the implementation. Let's see it with the help of example. So what in interface there could be abstract method, default method and the static methods. So abstract method is the part that define what should be done and not how, and the how is provided by the class that implement this interface. So let's see it with the help of example how we can improve this design using using abstraction. So basically we have one class known as checkout class in our previous example, and in this there is one method called complete purchase. So earlier this checkout class directly depend on the payment processor. So instead of directly depending on the payment processor, this checkout class will use an interface known as payment processor, and this payment processor will be the interface. And what does this interface does? This only define what should be done. I think so this will only specify what should be done. Like basically this interface provide what the class checkout class needs. So what is the need of the checkout class? The checkout class need the process payment. So this interface will provide what needs to done. So what needs to done? The payment should be processed. So process payment should be done. So So this interface define what should be done, what should be done, this interface define like process payment. So how part, where, so who will define the how part? So how part is defined by the class that implements this interface like PayPal processor and the Stripe processor. So we have two class, PayPal processor and the Stripe processor, that implement this interface and define this process payment method, and that is decide this how part. So basically we have improved our design using the interface like the checkout. What does the checkout class needed? Checkout classes needed the process payment, and this process payment can be provided by different payment provider, different ways. So basically, so what we have done, we have used the interface, and now the checkout class does not directly depend upon this payment processor. Instead it depends on this payment processor interface, and now different classes implement this interface and define the implementations. So let's code it and understand how it helps us to achieve the loose conflict and what is the abstraction. So instead of directly depending on implementation, the checkout object now depends on the interface like a contract. So it's instead of directly depending on an implementation, the checkout object not depend on the interface or contract. So checkout can use any object implementing. So checkout class now can use any object implementing this interface instead of being stuck to a specific implementation. So earlier what the checkout class was doing, it directly defined what and how both, but with the help of interface it only defined what needs to be done like process payment. Then how is specified with the class that implementing this like different class that implement this interface. So let's code it and see the real difference. So basically currently our checkout class depend on directly on it. So first let's create one interface named payment processor, and in the payment processor we will create one method known as void process payment. So the interface only define what's need to be done. So payment should be processed, and what it's take double amount. So basically by default all the methods in the interface is by default public and abstract by default. So we don't need to write here, basically we don't need to write here public abstract, because all the method in the interface is by default public and abstract. For example, here we can see modify abstract is redundant for the interface methods. So basically we can remove here because by default all the method in the interface is public and abstract by default. So basically we have created one interface known as payment processor. Now instead of our class directly defining both what and how it needs, now the checkout class will only define what it needs. So what the checkout class needs? The checkout class needs the payment processing. So basically instead of defining all this, what does the checkout class now does? Checkout class, instead of defining both what and how, we will only define what it needs with the help of our interface. So let's create private final payment processor and here payment processor, and now inject this dependency using our constructor payment processor, and here we will inject the dependency this dot payment processor is equals to payment processor. And in the complete purchase we don't need to do this, we will only write payment processor dot process payment. Let's first hide it and let's see. We will hide this, and what we will do, we will write complete purchase, and here we will write double amount, and here we will only write payment processor dot process payment of our amount, and we will write payment completed like checkout completed. Thank you. So what we have done, So our checkout class now only define what's need to be done using the our interface, and it only define now how part is defined by the class that implement this interface. So we our both this class will implement that interface known as what it needs our payment processor, and we will override this method override, and we will write here public, and in here we will also implement the interface payment processor, and we will, since it's so, we will write here public, and we will override this method. So now what we have achieved, so currently our checkout class does not directly define how it both what and how it needs. So checkout class only define what it needs. So basically it needs a process payment, so the checkout class uses this interface and define this what. So now the class that implement this will define how part. So now our class, so our PayPal processor implement this interface, our Stripe processor uses this interface. Now let's see how we can add, how we can use it in our. So let's delete this also, because this is making taking a lot of space and making our code very clumsy. So in the app, what we will do now, we don't need to do all this stuff. So let's first remove this, and we will create now, instead of the type of our PayPal processor, what we will do, we will create here of type payment processor, because it is our PayPal processor implement this payment processor. So this PayPal processor can be of type payment processor, and this will also be of type payment processor. If you don't understand it, you need to learn the Java concept of overriding and polymorphism. Now what we will do, we will create checkout, and here we will create new checkout, and let's see here checkout with PayPal, and here we will pass our PayPal processor, and let's see whether it's working or not. Checkout with PayPal dot complete purchase, and let's say amount is about 300.7. and now let's create with checkout with Stripe is equals to new checkout, and pass here our Stripe processor, and checkout with the Stripe dot process payment complete purchase of, let's say, 500. And let's run this code and let's see whether it's working or not. So you can see first payment is completed using the PayPal API, and the second the payment is done using the Stripe API. Let's say later we want to add one more. Let's say now in the future we want to add one more payment processor. Let's say in the future we want to add one more payment processor like Razorpay processor, or let's say crypto processor. Then we will simply write it and implement this interface known as payment processor, and void complete process payment. We will override this method of our interface public void process payment double amount. Why there is showing error? Okay, here double. Now this, and here we will write SOUT, simply doing payment with crypto processor, and now SOUT payment of, let's say, payment of amount completed using crypto. So we have added our so let's say we want to add our new crypto processor, then we don't need to change the code in our checkout class. Our checkout class will remain this only. We will only add our new crypto processor, and in now we in the our here we will only write checkout with crypto, and we will only pass this dependency by creating new checkout, and we will pass our new dependencies. So let's first create crypto. So it is a type of payment processor, crypto processor. Crypto processor is equals to new crypto processor, and let's here pass the crypto processor. And now let's check out with crypto dot process complete purchase of, let's say, $600, and let's see whether it's working or not. So basically we have added our new payment processor known as crypto processor, and we don't change any code in our checkout class, and let's see whether it's working or not. So you can see doing payment. So let's comment all this code, and let's see whether it's working or not. So as you can see, doing the payment with the crypto processor, payment completed using crypto processor, thank you, payment completed. So have you seen, using the interface we have only added the new payment processor, and we don't change any code in our checkout class, and hence we can use our same checkout class for the different implementations. So this is the advantage of using the abstraction. So with the help of abstraction, what we have done, so with the help of abstraction, basically our checkout class does not directly depend on payment processor or stripe processor. It depend on our payment processor, and depend on what and not how. So we can see that basically using this, we don't need to change that any code in our checkout class, and we add in new dependency, like we have added the crypto processor, and we provide this implementation of the process payment. So our interface only define what it's need, and our class that implement this interface define how it should be done. So this is the example of interface, and how interface help us in achieving the abstraction and decouple the implementation or the responsibilities. So let's see. Now we have understand the interface and how the interface can help us in achieving the abstraction. Now let's see how we can use the dependency injection with the abstraction. So let's see how we can add the spring. Now in the given example, let's add. Now what we will do? Now we will add. Now let's see how we can add the spring and use the spring IOC container for the dependency injection. So this can be done in the two step. First, we need to add the spring context dependency in our project, and the second, we need to create the spring context and add our beans to the spring context, and add the beans to the spring context. And third, establish the relationship using the auto-wired annotation. So let's see how we can do this. So this can be achieved in the 3 step. So let's do one by one. So first we will need to add. Come here to the pom.xml, because we have created using the Maven architecture. So we will get this pom.xml. If you are not seeing this pom.xml, so you need to create the new Java project using the Maven architecture type. So let's add the new dependencies of the type. Here type org.spring framework, and here type the spring context, and reload the program, and for the suggestion, close it once and then reopen it. So now it gets open. So now come to the app, and let's here what we need to do. We need to first create context where, and let's comment all this code, and let's create first context is equals to new annotation config application context, and here we need to pass, and since it's giving error, click here, alt enter, and convert here to the language. Now we need to create one config class, so let's come here and add one project config class. We have learned all this about how we can, so our first step is done. Basically what we have done, so our first step is to what was our first step was to add the dependencies. What was our first step? Our first step was to add the dependency. We have added the dependency. Second, we need to create the context, so we have created the context. Now we need to add the beans to our Spring context. So how we can do this? So come here and type first here, type configuration. And how we can add that beans to our Spring context? There was two ways. First one is the stereotype, and first one was the using the bean method call, and second one is stereotype annotations. So we, in this video, we will use the stereotype annotations like @ component services repository, like that. And so we have learned all this about in our second video. So you haven't watched this video, first go and watch that video and come here, and then we will write here component scan, and here we will type our base packages. Where is our base package? As you can see here, org.example is our base package. So what does this say? That hey, Spring, go to these packages and find all the component that are marked with annotations. So now what we need to do now, our Spring context is created, but currently our Spring context is empty. Now we want to add the beans to the Spring context. So so that Spring can inject the dependency automatically and provide the different features. So what we need to do? So what are the beans that needs to be added here? So first one is our checkout class needs to be added. Our payment processors, all the payment processors should be added here. So go to the checkout class and write the component annotation. Go to the package class, write the annotations. So let's first come to the checkout class, come here and type here annotations @component. So now what does it tell? So basically project config, we have typed here our package. It come and see the okay, checkout class is marked with annotation. Spring will create its instance and add it to the Spring context. Now this checkout will become one bean. Also we need this Stripe payment processor. So come here and write here @components. In the PayPal processor we also need to come here and write here component, and in the crypto processor come here and write component. So all this will be created by Spring and added to the Spring context. And now here we were doing the manual dependency injection. Now we want the Spring to add the dependency to our project. So come here and type here auto add. So what it will do, now the Spring will come here and see auto add annotation and mark and inject the dependencies from the context to this field. So now all this done. Now let's come to the app project. Now we don't need to create this instance with ourselves, because Spring will create the dependency, create it and add to the bean. So we don't need to create all this. Now what we can do, we can simply come here and type. So what we need crypto processor, checkout with crypto. So checkout. So what we will do, we will come here checkout. We want the instance of the checkout and name it checkout with crypto, and here we will write context dot get bean and type our class whose bean we want, checkout dot class. Now we don't need to create. So what is happening here, we don't need to create the instance. We don't need to create the instance of any of this class, because Spring will create the instance for us. And come here in the checkout class and add the inject the dependency into it, and let's run it. But it will give, are you able to to find one error in this. So let's run it and see what is the error in this code. Okay, so basically we haven't passed here, so passed here project config dot class. Still there is one error in this code. Let's run it and see what is the error in this code. So let's see what is the error that is saying it. So basically it's saying that no qualifying bean of the type payment processor. Why? Because here the now the bean has created all the four beans: checkout, stripe processor, paywall processor, and the crypto processor, and added it to the Spring context. Now it come to here payment processor and sees that it needs to add the payment processor beans into this field, but expected single but found 3: crypto processor, PayPal processor, and Stripe processor. Basically what is happening is that Spring inject the dependency by the type. So it comes here and sees that there are 3 types of the same type, like payment processor of the type payment processor, because all these implement the payment processor. So this is the type of, this is the bean of the type payment processor. This is also the type of the payment processor, and this crypto processor is also implement the payment processor. So it is a type of payment processor. So Spring tries to inject into this payment processor one bean, but it found the 3 beans. So how we can resolve this ambiguity? Let's see. So when we add the Spring, so what the Spring does is Spring create the object for us, manage the dependency, and inject the implementation automatically. So Spring understand the abstraction and inject the implementation. So why this error is coming? So let's see why this error is coming. So basically there is a multiple implementation problem error. So what is the problem scenario? So what is the scenario in our case? There is only one interface, like the payment processor, but there is multiple implementation: PayPal processor and the Stripe processor. So in Spring must inject one. So what is happening here is that here in the Spring context we have our Stripe processor, PayPal processor, and the crypto processor. All is of the type of the payment processor. And the checkout class, we have written the payment processor, and the Spring tries to inject one, but it found the 3 implementation of this payment processor, but Spring only can inject one. So therefore it's giving error, like as you can see here, no qualifying bean of the type payment processor. Why? The payment processor is implemented by the 3 classes, and all the 3 beans are available in the context. So the Spring is not able to identify which implementation to inject into this field, which should be injected in this field. Like here we can see that 3 beans are found: crypto processor, PayPal processor, and Stripe processor. So let's see how we can remove this ambiguity or solve this ambiguity. So the first solution is using the primary annotations. So first one is the using the primary annotation. Like we can mark any implementation at the rate primary. So basically using the primary annotation, we mark one implementation as default using the primary annotations. So by default, the Spring will add that implementation to our project. So let's see how we can do this. So what is the result? The Spring inject this implementation automatically, and will be no error. Let's see. Basically in here, first come to our app.java, and here its name is little bit trickier. So let's name it to checkout only. Checkout.complete purchase. Now it's currently giving error because there is 3 implementation of the type found. So let's come here and mark this type processor as the type of primary. So Spring will, if there is a multiple beans of the same type, then this will be getting more priority and it will be injected by default. So basically we have made our Stripe processor as the default implementation using the primary. So if there is any ambiguity or more than one type of bean found, this will be injected automatically. Let's see. Now it will be Stripe processor, so the payment should be completed using the Stripe processor. Let's see. Now you can see that now our Stripe processor become the primary beans. primary bean and it is injected in our checkout class. So this is, since it become our primary bean, so in the checkout class this stripe processor is injected into this field, and using this the process payment is completed. Like this process payment is completed using this only. So if we mark, like if we remove the primary annotations from here and write the primary annotations to, like let's say PayPal processor, and write here primary, and now if we try to run it, then our payment will be happen through the PayPal processor. Let's see whether it's correct or not. So you can say that connecting to the PayPal UPI and the payment is completed using the PayPal. So this is the first way of removing the primary annotation, use multiple implement ambiguity due to the multiple implementation. So let's see when to use it. When to use the primary annotation, like we will mark one annotation, one bean as primary by making the primary. So if there is any multiple implementation found of the same type, then the Spring will inject this implementation automatically. So when to use the primary? So we should use the primary annotation when one implementation is the default and when choices rarely change. But it is not ideal when the behavior varies dynamically based on some runtime condition. Then this should not be used. Then what should be used in that case? So in that case, the solution to using the qualifier annotation should be used, and it is recommended to use it. So now, so in the dependency injection, we have learned about this also. So what do the qualifier does? So in the dependency injection, the qualifier will inject that bin whose name is matched with it. So what we do? So how the injection can be happen with the help of qualifier annotation? Let's see. Come to the here, and in that dependency, the place where the Spring is injecting the dependency, come here and type here qualifier and passes the bean name of the bean which we want the Spring to inject here. So basically we have three types: stripe processor, PayPal processor, and the crypto processor. And by default, the name of the bean that is created is the name of the class name in the lowercase. Like for example, if we want to inject the stripe processor, come here and in the qualifier tab, right here stripe processor. This is the name of the bin that is created by the Spring. Stripe processor is name of the class, so the name of the bin is also the stripe processor. Only difference is the S is the small. So now if we run it, the Spring will come here and see here we have explicitly marked which bins to inject here. So stripe processor should be injected here, and when we run it, the stripe processor should be injected. You can see that the connection to the Stripe API verifying the credentials. So you can see that the payment is done using the Stripe processor. It means that here the Stripe processor is injected here. Now let's see here, if we write PayPal processor and if we come here and run it, then the payment will be done through the PayPal processor. As you can see here, connecting to the PayPal UPI and this one. So this is the type of the qualifier. Using the qualifier, we explicitly tell the Spring which bins to inject in our dependencies. Now we can also rename our bin. Here, come here, we can rename it. How we can rename it? Here, come here, and in the name, like write it something else, like it is of type stripe. So basically type here stripe. So now by default the name of the bean will be the stripe. So instead of the stripe processor, come here, and if we write stripe, then this name, the stripe processor, will be injected. Now you can see stripe is injected in our dependencies. So we can rename our beans using these annotations, and we can explicitly mark the Spring which beans to inject using the qualifier annotations. So this one is more recommended because this is explicit. We explicitly tell the Spring which beans to inject, and it is very clear and it is best for the real project. So this comes to the end of the video. So now you can easily design. After this video, we can easily design the loosely coupled system and understand the real world Spring code and debug the dependency injection and the ambiguity issues. Now after this video, so what we have learned in this video, so in this video we have started with what is abstraction, like what is abstraction, why there is a need of abstraction, how we can achieve the abstraction using the interface, and then we have learned about the different methods of the abstraction, like using the interface and the abstract classes. Then we have learned how to use the dependency injection with the abstraction. So this led us to the end of the video. So what in the next lecture we will learn about the sprint scopes and the life cycle. So thank you.